what's interesting about this particular problem is that there's more than one way of doing it. And actually, I think of the, how many groups do we have here? 8 groups. I think there's 4 different ideas that have emerged. And I think it's kind of useful to look at the various ideas. So, so here's the first idea that several people had. They said, okay, we're going to be looking at this thing a character at a time. And so we have this index I. And now we check, is it a vowel? And so over here we find that this thing is a vowel. And then they said, it's a vowel, so I need to consume all the other vowels as well. And so you can do that by having a loop inside a loop. And so over here we can say while
n squared.
while the I plus first character is a vowel, we keep incrementing I. And also, I guess we need to increment our counter, right? So let's try this. So I is 0, my letter is B, is not a vowel. I is 1, my letter is E, so I'm now here. It is a vowel. Is the second character a vowel? Let me make little numbers here. Is the second character a vowel? So I increment. Is the third character a vowel?
Yeah.
Is the fourth character a vowel?
No.
Okay. So now I do count plus plus, so I forgot my count. So. And now I come back. Is I less than the length? What's I right now? It was 3. Is I less than the length?
No.
It is less than the length. Right?
Yeah.
Right. So that what's the ith character? What's the ith character? I is 3. Oh, I said this before and I say it again. You have to look at the value that's there, that's actually written down, not at the value that you would like it to be. The point of having the pseudocode is to find bugs, subtle bugs in this thing before you waste a lot of time coding it up. So I is 3, right? The last increment here, set it to 3. What's the third character?
A or U.
It's U. Okay. Is it a vowel?
Yeah.
Why the heck am I in here again? I was supposed to skip past all of the vowels. And that means that somewhere there's an off by 1 error. Maybe I should have incremented 1 more time here, or maybe I forgot an I++ at the very end of the loop, or something. These things happen all the time. The point of doing this exercise is to find these kinds of errors. And so this thing, as it is not perfect, but the basic idea is there. And now the back-breaking labor is to go through and make sure that all of the i's get incremented the right place, that there's no other kind of errors. What other kind of error are we likely going to run into this thing here? Yes?
When the last character pops up.
So let's say we're all the way back here, where I is 5, and now we're asking, is the 6th character a vowel? What's going to happen?
It's going to throw an exception.
It's going to throw an exception. How do you guard against that?
Catch.
No. No. How do you guard against that?
It's fading.
Okay.
It's gone. I'm sorry, how do you guard against what?
So the problem that we have is that if we're at the very end, and now we're looking at the I plus first character.
Oh, and there's nothing
it's,
there.
It's not there.
So you need
the program will die.
Another if statement?
Yes.
Like if I plus 1 equals nothing, like.
So and actually you probably want to put the condition right in here. You want to say something like, while I is less than, someone said length minus 1, that sounds good. And the I plus first character is not a vowel. So it's that kind of guard that you can, you will find that out by running through an example that has a vowel at the end, such as beauty, because we consider Y a vowel. And you want to test these things in your walkthroughs before you commit the thing to code, because it's easier to catch these things early on. All right, so that was the idea number 1. Let's look at some of the other ideas that people had. And so the thing that makes idea number 1 a bit unattractive is having in a loop looks scary. So idea number 2 that people had is they said, I'm going to look at this guy here, the E now, and I'm going to also remember that previously I had a consonant. And whenever they have a transition, first a consonant, then a vowel, that should be the start of a vowel group. So how do you look at the thing to the left?
Minus 1, you say.
You could actually do that. You could look at the minus 1 character. But what one group did that I thought was interesting is they did a loop that looked like this. They remember the previous one in a variable that I call old. Every time that they are done with a loop, they remember the previous one in this variable. And then when you come back, then you have the previous one stored in that variable. And then you can compare the old and the new. This kind of remembering the previous is often a good idea. When you are through a loop and you need to look at adjacent things, then remembering the previous is a great trick. This happened to us once in some lab that we had about, or in a homework about a spinning disk. Remember the spinning disk? That was also something where one had to remember the previous one. So that's a kind of a good strategy. And so that's a good plan. I didn't fill in all of the details. The people who did this struggled with what happens at the very first iteration when you don't yet have a previous. So I guess here we have to say if I greater 0, because I equals 0 was the first step. Other people used the kind of the opposite approach. So this was idea number 2, was remember the previous. Yeah, remember the past. Yeah. The ones who don't remember the past are condemned to relive it. So remembering the past is good. Other people were more forward-looking. So this is number 2. So strategy number 3 was to look ahead. And so what they did is they looked at the ith one, and then they looked at the I plus first one. And when the ith one was a vowel, and the I plus first one was also a vowel, they didn't increment. But when the ith one was a vowel, and the I plus first one was not a vowel, then they incremented. Right? That also works. And then, of course, you have a complexity with that strategy. Where do you have to pay attention?
It's at the end.
At the very end, right? You can't look past the very end, and so there you have to have a special condition at the very end. But it's a reasonable idea, right? You look at pairs, and when you find a transition from vowel to non-vowel, then you increment the code. The fourth strategy, I guess the fourth one was kind of like the second one, except they didn't remember the previous character. They set themselves a Boolean flag that remembered whether the previous one was a vowel or a consonant. So they would set this flag, and it was false, true, 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 false, true. And so when they saw the vowel, then they say, was the flag false? And that also gave them a memory of the past. And so that will also work. It's kind of the same thing as number 2, except that the way they remembered it was in a Boolean variable instead of remembering the last character. It's a little bit more efficient because you only have to ask this question once. So those are all good ways of doing it. And so there's 2 different things that we learned from this exercise. Number 1, there's lots of different ways of solving a pretty simple problem. We have all these different strategies, they all work, and you have to kind of settle on one and then carry it through to its bitter end. And number 2, these strategies are now complicated enough that something is likely to go wrong. Every one of those strategies, I saw people, they forgot to reset the Boolean variable. They messed up the counter in one of the branches. They overstepped the end of the string. This will happen to you all the time. Your life will be this for the next few weeks. That all of these little things go wrong. So to effectively program, you have to do 2 completely different tasks. Number 1 is you have to have the grand vision, the plan, to come up with a strategy that breaks everything down into tiny steps that the computer can do. Fetch the ith character, fetch the i+1 first character, run the loop, compare, check whether this thing is true, check whether this thing is false, check whether both of these conditions are true. You have to do the breakdown into these teensy steps. And then number 2 is you have to get the itty-bitty details right. That all of the i's have to be in the right place, the increments, you can't overstep the string bounds. And it is genuinely not easy stuff, and you need to set yourself some time for doing this. So particularly in the homeworks that are coming in the next several weeks, I've talked to several people who said their strategy for the homework was that on Monday night at 9 p.m. they were going to get themselves a large soda and a sandwich, and they're going to start coding. And on Wednesday at 9 p.m. they would do the same thing. This cannot work because there's all these little things, several things that you have to do to get any one of these problems going. And they're all just hard enough that you just can't do them in 3 hours. So you have to work on these things every day. Every day that you're not coding is a day that you're not doing it right. So you have to code Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Maybe for an hour a day, for an hour and a half a day. And that's the key to success. So tonight, go forth and code. On Friday, you go and code. On Saturday, really. And that's the way to do it. And every day, you either get something to work that didn't work before, or you put a question on desire to learn. I want to see lots more questions on desire to learn. All right. It may happen that I'm going to be caught in a meeting. I'm supposed to talk to the department chair for 15 minutes, and it usually doesn't end in 15 minutes. So if I'm late, if I'm not here at noon, go on with the next lab. And the next lab is, I'll come back and rescue you later. So finish up what you had with this lab. We've milked it to death. The next lab is lab 7A or 7B, I don't remember. It's one that we skipped before, and I need it as prep for lab 8B. So it's back in 7, and it's in the Dropbox. All right.